In aviation, understanding aircraft weight definitions is a crucial skill. In this video, I'll explain every type of weight that you need to know. The starting point for weight computations is the basic empty weight. This is the weight of the standard aircraft optional equipment, unusable fuel, and all operating fluids, including engine and transmission oil, and hydraulic fluid for those aircraft so equipped. Dry operating weight. This weight is calculated based on the aircraft's basic weight, plus the weight of the cockpit crew, cabin crew, and their luggage, as well as the weight of any catering loaded onto the aircraft. An aircraft has many dry operating weights. These values vary depending on the number of flight crew and the catering loaded onto the aircraft. It is indicated on the load sheet. Zero fuel weight. Zero fuel weight refers to the weight of the airplane without any added fuel. It includes the weight of the airplane, the crew, passengers, baggage, and cargo, but no fuel. Imagine your aircraft ready to go, but sitting on the runway with empty fuel tanks. That's your zero fuel weight. Why is zero fuel weight important? Because it limits the total weight of the passengers, crew, and cargo. If you exceed this limit, you could place undue stress on the aircraft structure, as the wings, where fuel is stored, provide significant structural support. In other words, if the weight of the fuselage is too heavy compared to the weight of the wings, additional stress is placed on the point where the wings connect with the fuselage. Takeoff weight. Takeoff weight is the weight of the airplane just before the brakes are released to begin the takeoff roll. This weight includes zero fuel weight, plus all the usable fuel needed for the flight. It's essentially your ramp weight minus the fuel used for engine start, taxi, and run-up. This weight is of critical importance as it directly impacts an airplane's performance during takeoff. More weight means longer runways are needed for takeoff, slower climb rates, and higher stall speeds. Therefore, every aircraft has a maximum takeoff weight that must not be exceeded to ensure safe flight. Landing weight. Landing weight refers to the weight of the airplane when it's ready to land. Simply put, it's the takeoff weight minus the fuel burned en route. Fuel consumption plays a significant role in this weight calculation. As the aircraft flies and burns fuel to keep its engines running, it becomes lighter. So, the weight of the airplane when it touches down at its destination is less than when it took off. Understanding the landing weight is critical because it directly impacts the safety of the aircraft. Each aircraft has a maximum landing weight, which is the heaviest weight it can safely land at without causing undue stress on its landing gear and structure. If the landing weight exceeds the maximum landing weight, it could harm the aircraft's structure or cause a catastrophic failure. Therefore, pilots must manage their fuel consumption and cargo load to ensure the gross landing weight stays within safe limits. Why is weight so important? Weight has an impact on aircraft performance, takeoff, and landing. Heavier aircraft need longer distances for takeoff and landing. The length of the runway has to match the distance required to ensure safe takeoff and landing. If the runway is too short, the overall weight of the aircraft would need to be reduced. Fuel consumption. More weight means higher fuel consumption, which affects the efficiency and cost of flights. Payload and range. Increased passenger weight can reduce the amount of cargo an aircraft can carry, or shorten the distance range the aircraft can travel.